Hi everyone, my name's Will. I'm a security engineer at Sourcegraph. So about 18 months ago at Sourcegraph, we were having a sort of recurring issue with containers. And I think it's an issue that probably a lot of people here are also having, vulnerability management. So Sourcegraph is a code search tool, and it lets you index source code from wherever it's stored, run queries against it. And because source code is such like a sensitive asset, some of our customers want to run our product on their own infrastructure. And these security-conscious customers, they also want to scan the containers. And then some of them, the very picky ones, if there are any high or critical vulnerabilities, they won't even deploy a new version. So this was causing us a lot of trouble internally. And there's a whole other talk about vulnerability scanning and all that. But in general, we don't want to ship containers with vulnerabilities in them. And having this issue with customers meant that we had a really solid business reason for sort of like putting a lot of time and effort into trying to figure out a solution to this and seeing how we could reduce this pain point. So one of the things we started looking into was Distroless containers, and we found a lot of benefits there. But what we didn't find was really many success stories of anyone actually adopting them successfully. So after doing some research, we decided to make a bit of a bet on it, and I led a project to migrate all of Sourcegraph to Distroless. And it wasn't a straightforward project. It took a while, but we did see a bunch of benefits. And one of these was fewer vulnerabilities. So before this project, we were averaging 30 high and critical CVEs in each release. Obviously, these weren't actual CVEs. We triaged them and we made sure they didn't affect us. But that's a huge burden on security. It's on customer support. Maybe reduces customer trust if they see that many CVEs. And switching to Distroless after the project, we got down to 0 CVEs. Obviously, it started going up again immediately, but it was at a slower rate. And getting down to 0 meant we had less toil. We were able to deploy some consistent automation for one-click patching things when they came up. And we also saw an increase in customer happiness. That's a hard metric for security to influence normally. And it's quite hard to measure, but one data point is that we had a huge customer where every release we had weeks of back and forth where we would cut a release, we would give it to them, a week later they would scan it, they would find new CVEs that come up in that week. Then they'd send us an Excel file of vulnerabilities. We would review them. We'd send a release, and around and around you go. And after we switched, that just disappeared. That work just disappeared. So we estimate maybe 10 hours of time saved per release. And as we release every 2 weeks, that adds up pretty fast. And we saw a few side benefits as well. So there's a reduced attack surface because there's less stuff in the containers. And once we used some additional tooling, we managed to get reproducible builds as well, which is a nice supply chain feature. So I kind of think Distroless is really interesting because there are a lot of security benefits to it, but there isn't much information out there and it's not very well adopted. So the kind of goal of this talk is to help you understand what it is, how it can be a powerful security tool, and whether you might actually want to use it. As with everything, there are trade-offs, so it's not the right solution for everyone. But even if it's not, it's kind of an interesting way of building containers that looks at the problem a bit differently. So I think there are definitely some lessons there. So in regular containers, you have your application, but you also have a bunch of tools, libraries, other packages that come as part of your base image. And Distroless containers take a different approach where they don't include anything by default. And the idea is that you just install the base dependencies, just the bare minimum of what you need for your app to run. And that extends to not having a package manager in there, not having a shell in there. So it sounds pretty extreme, but there are a bunch of benefits. The obvious one is attack surface. Say the worst happens and someone gets remote code execution in your app. It's much harder to get a reverse shell from that if there is no shell in the container. Still possible, but harder. And it also makes your containers more secure, and it has a really outsized impact on vulnerability management. But the biggest benefit we saw is there is just less stuff to accumulate vulnerabilities. So the amount of work you have to do just slows right down. So to kind of put it into context, I want to start with a really simple example. So I wrote a very straightforward hello world Go binary. And I started by shipping in a Ubuntu container. Ubuntu is a great distro. I expect some people here use Ubuntu. And that ended up being 105 megabytes. So for a hello world, that's pretty big. There's a lot of stuff there we don't need. And the next step, I expect most of you would probably say Alpine. Let's look at Alpine. And that gave us a container that was 10 megabytes. So that's doing a lot better. But the binary is 1.4 megabytes. So that's still 9 meg of stuff that we don't need. So kind of approaching it from a Distroless direction, because it's a Go binary, it's entirely self-contained. We can just use an empty container and ship it in that. And that gave us a container that's 1.4 meg. So there's literally nothing else in there but this binary. And to prove it works, little hello world. So, it's important to mention that having stuff sitting around in the container doesn't make it suddenly vulnerable. The attack surface on this container is tiny, so it's probably not going to be any less vulnerable. But, as security engineers, we're kind of beholden to vulnerability scanning. So kind of to illustrate this, I built these about 4 weeks ago, and I scanned them a few days ago. And the Ubuntu container had 15 vulnerabilities in it. The Alpine container had 2 vulnerabilities in it, and the Distroless container had 0. And that kind of just indicates that even though they're doing the exact same thing, some of them are just accumulating vulnerabilities at a much higher rate. So the first time it kind of worked, and maybe people are thinking, oh, this Distroless stuff sounds pretty good. But the real world is a little bit messier. So, say we update our application to fetch a web page or something simple like that, and we use the same empty Distroless container as before. So our application goes to the server. The server says, here's my TLS certificate. And our application goes, what do I do with that? So the problem is that Go relies on the system's root store for TLS. So because it's an empty container, we don't have any root certificates there. So it doesn't know what to trust. And there's another example, like Sourcegraph makes code searchable. So it needs Git, and Git needs Perl, it needs libcurl, it needs all these other dependencies. So although we kind of said a few slides ago, we don't want a package manager, we kind of need something like that to manage this dependencies for us. So let's kind of move on to how we solve that. So you're probably familiar with how you build a normal container. You take a Docker file, you start with a from line that pulls in an image that someone else has built, and then you install packages, you copy in your own files, and then you run Docker build and you get a container out the other end. And what's different with Distroless is that instead of using this upstream image that someone else has built, you build it yourself and it's customized to exactly what you need. So kind of the way you do that is you start with an image blueprint and you basically list any packages you need, any users, directories, things like that. And then you run it through some tooling, so a bit of Distroless tooling, and then you get a base image as the output. So for example, in the previous example, we probably want the CA certificates package because we need to verify TLS connections. And for Sourcegraph, we might want to install the Git package and some other things. So when I say Distroless tooling, there are kind of 2 main tools out here. So Google Distroless is a really good starting point. They provide pre-built images for different runtimes, so Go, Java, Python, all that stuff. And if you've got really simple needs, if you just want to run a Python application with in as minimal container as possible, it's a really good way to get started. The problem with that is if you want to then customize those containers, I said Sourcegraph needs Git. If you want to add stuff into it, you need to start using the Bazel build system, which has a very steep learning curve. So that's kind of a problem you'll run into. And the second piece of tooling is AppCo, and that's what we landed on at Sourcegraph. So that's much easier to get started with. You basically write a simple YAML file, run it through AppCo, and it will give you an image that's kind of pre-built and entirely customized to what you need. So this is a really simple example of an AppCo YAML file that describes a Distroless image, which our Go binary can use to fetch web pages. And you can see here it's pulling packages from the Alpine repo. It supports any Linux distro that supports the APK format. And here we're just installing the CA certificates bundle. That's all you need, really, for this particular case. So if you're thinking this sounds interesting, I'm going to share a few kind of best practices that we came up with. So at Sourcegraph, we migrated around 30 containers. Sourcegraph is kind of like a fairly complicated SaaS application. And we did that in kind of one big bang. So one release, we had all the old images, and the next release, we kind of shipped everything Distroless. And that worked quite well for us because Sourcegraph is like a single product. I think if I were approaching it from a different perspective, if you've got maybe some Java containers, some Python ones, some Go ones, kind of pick an ecosystem and start targeting those. Start targeting them one at a time to sort of focus your attention. And the next one is to kind of make it simple for devs to use. Most devs know how to use Docker, and if you take that away, they might get a bit grumpy. And Distroless kind of changes how you think about Docker files. You do less work in the Docker file than you do more in the base image previously. And people won't know how this works straight away, so you need to kind of make sure you've got good documentation, and it can be self-serve as well. Expect a few rough edges at the start, but over time, developers will kind of get used to it, and it's going to go smoothly. And Distroless kind of enforces best practices, and I think if you look through your company's Docker files, you'll probably find a few that are definitely not best practice. So maybe you're fetching a binary from GitHub, maybe you're downloading some source code, building something in the container. We found a lot of things like that when we were doing this. So the way we solved that was actually following good practice. So we set up a package repository ourselves. So we then package these dependencies and can just include them in this build process. And not on the slide, but at Sourcegraph, we also adopted Bazel. And we're using an APCO rule set, which makes it easier kind of simplifies the build process for us, and it lets us build fully reproducible images, which is a nice thing you can get when you're using APCO. So the main trade-off with this is you're kind of taking on additional complexity, and you're trading that for security and compliance, security and convenience. So it's sort of like you're slowing down a bit, but the idea is you will go faster because adopting Distroless has the upfront work, but over time, you'll have easier vulnerability management. And then there is a technical switching cost. If you're switching to a new Linux distro, that obviously takes some time to migrate over and to test, and you'll need to unpick any sort of like bad practices that have crept in. And because you are now effectively managing your own base images, you're not relying on Alpine or Ubuntu to keep things patched for you. You need to write a bit of tooling to do that kind of stuff for you. So in terms of like changing dev mindset, I find most developers are usually on board with security improvements, so long as it doesn't block them. So if you've got clear documentation about how this works, and developers can make their own changes and they're not blocked, they're pretty on board with this kind of stuff. And then debugging complexity is kind of the last thing. Because you're removing a lot of tools from the containers, it can make it harder to debug the containers. If you don't have a shell, how do I get in? How do I SSH in and bundle around? So there are some solutions here. Kubernetes has ephemeral containers, which lets you attach a sidecar with debugging tools in it, and that's very convenient. We're still working on the trade-offs ourselves. We have some containers that have debugging tools just because it's worked out that we kind of need them, and it just makes life easier. So if you're kind of wondering, should I adopt Distroless? There are a couple of prerequisites I'd recommend. One is having a really mature continuous integration pipeline. So building things automatically all the time. I work really closely with our dev infra team to build up some of the tooling we needed for this. Because essentially you are maintaining your own base images. So that requires a bit more work. And the other is really that this isn't particularly low-hanging fruit. So if there's other low-hanging fruit, you should probably take a look at that first and kind of figure out, is there anything we can do to improve vulnerability management? But if you're happy that you've kind of ticked both those boxes, then it's really a question of what security requirements you have. Do they outweigh the switching costs? If you're in a regulated industry, or if your customers run your containers and then scan them themselves, maybe that answer is yes. For us, it certainly was, and we've seen a lot of benefits. Cool. I've set up a GitHub repo with the demos from this talk, and a few more examples as well. So if you're interested in kind of playing around with Distroless or getting started, the QR code goes straight to that repo. Happy to take questions if there's any time. I'd like to thank Greg, my mentor. It's been very helpful putting this presentation together. Thank you.
Applause. Would anyone like to ask a question? Don't be shy.
I've bamboozled everyone.
I think you just gave a very thorough presentation. So. Oh, we do. There you go.
That's a good question. How long did it take us to convince the developers? It was so at Sourcegraph we have a sort of internal RFC process where we submit a proposal. It didn't take as long as I was expecting. We had some quite good. I think developers knew that we were having trouble in this area, and they were kind of keen to not be blockers in this. And we did a lot of the heavy lifting for them. So in terms of developer changes, there wasn't that much to adapt to.
Another one over there.
Were there any non-security related benefits beyond obviously size?
Yeah, I mean size is one. I think for us we saw quite a lot of benefits because we started a project to adopt Bazel at the same time, which is a sort of build system that can build anything. So you can now, for example, you can say, build me this container, and it will go from absolute scratch. It won't, install the packages, build a container, build our binaries, put them on top. That was a kind of nice advantage we saw, because that gives us a really secure supply chain where everything's hashed, hermetically sort of like sealed and like immutable. So you can run the same command twice a week later and you get the exact same thing, which is something that's kind of harder with Docker, because you run it and then you might get a different set of packages installed or all sorts of things.
I think that's all the questions.
Great.
Thank you so much. Give another round of applause.